So here in output side, I have only one LCR in series. At the primary side, I have one LCR in parallel. So stage by stage, we are simplifying. So resistance in parallel at the primary side is combined into R01. Resistance in series at the secondary side is combined into Ri dash. This is one set of simplification what we have done. Okay, we are not satisfied with that, so I'm going to do one more set of simplification. And remember, since you're using a transformer, the effect of mutual impedance or mutual induction cannot be ignored. You will have the effect of capital M coming between L1 and L2 in your circuit. So here, now what I'm doing, I have this RL in parallel. So I'm going to convert that RL in parallel into RL in series again. So slowly, primary side also, I'm going to make all components in series. Okay. So see here, applying the same transformation formula, this L1 R1 in parallel has become L1 R1 in series. And again, what formula we'll be using? So you have to use this formula. LP equal to LS into RP equal to RS into. So if you use RL, use this formula. If you are going to use RC, you have to use this formula. The formula is already given to you. So use that formula and try to reduce your circuit. So ultimately in secondary side is stable now. I have single loop. Same way I have to ensure that I have a single loop in the primary side. So for that first simplification, what I am doing, LR parallel is being converted into LR in series. LR in series. And since now 3 loops became 2 loops, I want to make this 2 loops into 1 loop. So what I'm going to do, I'm going to replace this current source parallel to capacitance by a voltage source series with capacitance. If I do that, I will get a single loop in the primary side. So the old current source value is GM BB dash E. So you know V is equal to I into Z. So I is GM BB dash E. Across parallel to I have a capacitance. Capacitance, you know, Z is 1 by J omega C. So if you substitute, BM will be GM BB dash E by J omega C. So I can convert this current source into voltage source of this value, and this capacitance in parallel will become capacitance in series. So the final equivalent circuit will be this one. Very, 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 very important circuit. So you see, V1 is GM BB dash E by J omega C, parallel series with capacitance, series with L1, series with R0 dash. By secondary side L2, C2 dash, R1 dash. So this is the final simplified circuit of the output side. And V1 is the this voltage, and whatever it is entering your transformer is going to be capital V. Okay, whatever it is going to enter your transform, it's going to be capital V. So I'm going to write Kirchhoff's voltage law till this point using capital V. So you have 2 loops and you can write the Kirchhoff's voltage law equation. So V1, you can use these equations. These equations are tailor-made for a transformer. V1 equal to Z11 I1 plus Z12 I2. And in the input side, I have this voltage. Output side, I don't have any voltage. So 0 is equal to Z21 I1 plus Z22 I2. So this set of equations can be used for any network. What is Z11? Z11 is the total resistance at the input side. At the input side, you see primary side, okay? At the input side, one resistance R0 dash, and they have inductor in series. The impedance of inductor is J omega L1. So Z11, you see R0 dash plus J omega L1 series. So I am adding it.